This video is on quadratic functions, standard form. We're going to be taking standard form equations and rewriting them into factored form so we can find our roots. We're also going to be finding our minimum or maximum, our vertex, our y-intercept, and domain and range. So, quadratic functions, the parent function for a standard form is the f of x equals ax squared plus bx plus c. It is a quadratic trinomial. To find the roots, which are your x-intercepts, your zero solutions, you're going to find the roots by factoring and using the zero product property. What that means is what value of x will make the equation equal to 0. So quadratic functions on this one, we want to factor, which means we're going to use guess and check. We're going to have f of x equals, our GCF, our smallest number is 1, so it doesn't affect the problem. We're going to have our two sets of parentheses. I see that my c is negative, so I know I'm going to have two different signs. Factors of x squared are x and x. Factors of 8 are 1 and 8, 2 and 4. And I know that 2 and 4 can give me a 2, so I'm going to put in a 2 and a 4 in here. And I need to make sure that I get a positive 2 out of this, so my bigger multiplication should be positive. I should have a positive 4 and a negative 2. Now let's check it. So negative 2 and a positive 4 give us a positive 2. So this is factored form. Now I can actually use the zero product property to give us our roots, which is what minus 2 gives us 0. You can also just set this equal to 0. X minus 2 equals 0. So x equals 2. So our first root is 2, 0. So our m value is 2. And the other one is, if I set this equal to 0, x plus 4 equals 0, x would equal to negative 4. So it would be negative 4, 0. Those are our two roots. Max or minimum still comes from our a value. So our a value was equal to that positive 1. So it is still going to open up, and it is still a minimum. Now our AOS can be done slightly different than what we did in factored intercept form. We can actually still use our factored intercept form way. However, not all quadratics will have x-intercepts, so we want to be able to use another way of finding our AOS. Especially if it's in standard form, you can use x equals negative b over 2a. We have x equals negative. Our b value is the 2, not the x, just the number, the 2. So negative 2 divided by 2 times our a value was 1. So it's negative 2 divided by 2. X is equal to negative 1. Now to show you, you can still do the same way we did before. If you do 2 plus negative 4, that's a negative 2, and you're going to take half of that. So that's also a negative 1. So both methods work because this one does have x-intercepts. To find your vertex, we're going to do the same thing we did before by plugging in that negative 1 into the original equation and finding the y value. So to find the vertex, we're going to plug negative 1 in. So y equals parentheses negative 1 parentheses squared plus 2 parentheses negative 1 parentheses minus 8. The reason you plug it into your original is because if you accidentally mess up on factoring it and you plug it into your factors, you also get your vertex wrong as well. So if you do these two, you can still get your vertex correct regardless if you got your roots wrong. So negative 1 squared is 1. 2 times negative 1 is negative 2 minus 8, which is equal to negative 9. So our vertex is at negative 1, negative 9. Now the y-intercept is different this time because standard form actually gives you your y-intercept. Your y-intercept is going to be just 0, c. Whatever your c value is, that's actually your y-intercept. That means I can just write this as 0, my c value is negative 8, so 0, negative 8. That is our y-intercept. So remember, intercept fact form will basically give you your x-intercepts because it'll look like this. All you have to do is just change the signs on them. Standard form gives you your y-intercept, and vertex form, which is what we'll do in another video, will give you your vertex automatically. All quadratics should have the domain as negative infinity to infinity. And then your range, we need to find if it was a minimum or maximum. It was a minimum. So we have a min value. It's still the y value of our vertex, which is that -9. A was positive, that means we're going to have a positive infinity. And our -9 is on the left. Close, open bracket. The next part was the function notation. So again, function notation goes back to a f of x minus h, then plus k. As long as, if we're dealing with quadratics, if f of x equals x squared, then the function notation will be written as our a value is 1, f of x. Remember, this comes from our key point. Our key point is our vertex. So we're going to change that h value, so it's going to be +1 because it will be minus a -1, which is +1. And then that we're going to keep that k value, so that -9. This is function notation. This next problem, we're going to factor again. Our GCF on this one is -1. We have a negative out here. We never want a negative in the front, so if your a value is ever negative, your GCF should have a negative in it. It's -1 because the smallest number is 1, and there's no x on here, so GCF is -1. -1 parentheses. We're going to have a positive x squared, then a positive 4x, and then a -5, because we're just dividing all of these by -1. Now we can factor this trinomial. So f of x, put a little too far down, f of x equals -1 parentheses. We're going to do 2 sets of parentheses. Factors of x squared are x and x. Factors of 5 are 1 and 5, and that's it. But I need my bigger multiplication to be positive because my bx is positive. So my 5 will be positive, and my 1 will be negative. And let's check that. -1 times x, and then x times 5. So that's 5 and -1 will give us a positive 4. So this is correct. Now that we have it factored, we can find our roots. This one has an x with it, so 1 minus 1 gives us 0, so 1 comma 0. And -5 plus 5 gives us 0, so -5 comma 0. And these are our two x-intercepts. Our a value, now that we have the a value on the outside as well, but it was also the same a value from the beginning, a is equal to a -1. That means it's opening down, so it will have a maximum value. Our axis of symmetry is going to be that -b over 2a again, but we're going to use it from the original. So even though we factored out that negative, we're going back to the original. X equals -b. Our b value is actually, the original was -4. Over 2 times our a value. Our a value is -1. So we have negative times -4 is +4, divided by 2 times -1 is -2. So we have 4 divided by -2, which is equal to a -2. X equals -2. Going to find the rest of our vertex by plugging in that -2 back into the original problem. So we have y equals negative parentheses, -2 parentheses squared, minus 4 parentheses, -2 parentheses, plus 5. -2 squared is 4, so this is really in the beginning is -4 now because the negative on the outside. -4 times -2 is plus 8, and then we're going to add 5 as well. So that will equal to a positive 9, because that's going to be 4 plus 5 is 9. So our vertex is at -2, positive 9. The y-intercept, again, comes from the standard form. So again, go back to the original standard form. It's 0c, so it's 0, positive 5. 0, positive 5. This is why we always go back to the original. The only reason we do the factored form is to get the roots, and then from there we go right back to the original. The domain of this problem, as always, is -infinity to +infinity, because it's a quadratic. And then our range, because it was a maximum, we have a max value at 9 because that was our y value of our vertex. A was negative, so that means we will have a negative infinity, and we'll have our 9 on the right-hand side. Open bracket, close bracket. For function notation on this one, if f of x equals x squared, because that is our parent quadratic function, we can write our function notation as our a value was -1, f of x, key point is your vertex, minus a -2 is +2, parentheses, and we're going to plus our k value, so +9. This is function notation. This last one on here, we're going to factor out, we can automatically factor out that negative, and then our smallest number is 3, which 4 can't be divided by 3, so our GCF looks to be just a -1 again. So we have -1, parentheses, 4x squared minus 8x plus 3. We're going to have that f of x equals -1. We're going to have a parentheses. Alright, so the factors of 4x squared are 1x and 4x, and then 2x and 2x. So I'm going to start with 2x and 2x in the front. Then our factors of 3 are 1 and 3. I'm just going to put a 1 back here in the first one and a 3 in the second one. I see that my c is positive, so I'm going to have the same signs, and my bx is negative, so I'm actually going to have both of them are negative. So that helps. Now multiply. We have -2 and then -6. -2 and -6 give us a -8, so that one is good. We actually, it's already factored completely now. So we guessed and we checked it and it worked. So now that it's factored, we can find our roots. So our roots are slightly different here. This goes back to understanding the zero product property, is where you set the factor equal to 0 and solve. So x minus 2 equals 0, you added 2, that's where that came from. So on here, this factor, 2x minus 1, is equal to 0. 2x minus 1 equals to 0, so I need to solve this. I'm going to end up adding 1 and then dividing by 2. So my intercept is 1/2, 0. And this one, 2x minus 3 equals 0, means I'm going to add the 3, then I'm going to divide by the 2. So it's going to be 3 over 2, 0. So that's what the zero product property is when you actually have to set the factor equal to 0. Next up is our min or max. A value was, again, a -1, so this is going to open down. Means it's a maximum. Our axis is symmetry, the -b over 2a, so we have x equals -b from the original. That's that 8 right there, so negative times that 8 over 2 times your a value from your original is that -4. So we have -8 divided by -8, which is +1. X equals +1. So our axis symmetry is that +1. Now to find your vertex, we're going to plug in that +1 again back into the original. We have y equals -4 parentheses 1 parentheses squared plus 8 parentheses 1 parentheses minus 3. So we have 1 squared is 1 times -4 is -4. 8 times 1 is 8, so we have +8, and then we have -3. -4 plus 8 is 4, minus 3 is 1. So our vertex is, the x is 1, the y is 1. The y-intercept, again, comes from the original c value. So our y-intercept is 0, -3. Our domain, again, is -infinity to +infinity. And our range is a maximum, so we have max value is at that y value of our vertex is at 1. So since a was negative, we know we're going to have a negative infinity. And then our max value goes on the right-hand side. Open bracket, close bracket. And the last part of this is just to do our function notation. So again, function notation, if f of x equals x squared, because it's our parent function of our quadratic, we have a, which was our -1, f of x, minus that h, so that key point, again, from the vertex. We're going to subtract the 1, so -1, and then plus the k value, so plus that 1. This is function notation.